And it starts off by, so the three things we've kind of talked so far about are, number one, general antiderivatives for kind of what we call transcendental functions. So for example, what's the antiderivative of e to the x? E to the x. What's the antiderivative of 1 over x? Natural log of x. How about this one? What's the antiderivative of 1 over 1 plus x squared? Arctangent. What's the antiderivative of 1 over the square root of 1 minus x squared? Arcsine. Yep. So you learn those general antiderivatives along with their substitutions. So that should be hopefully something you're feeling very confident about. If you're not, tomorrow morning would be a decent time to come in and see me. Second thing we learned were slope fields. So we're going to pick up with just a little bit of a review of the slope field, and then we're going to get into what we call separable differential equations. Separable and differential equations. So that's our kind of our last piece. After we get done with that, you guys will review, and you'll take a test on Friday. We'll get to study guide tomorrow. And then we start the 1-month procedure of preparing for the AP exam, which is...
Good afternoon. If you were given an invitation for the meeting to be funded, please make sure you make it in. Have a great day.
If you, by chance... so we get a 1-month preparation for the AP exam. You can just see right here, today is this Monday. Senior's last day is the 17th. So you have 1, 2, 3, 4, 5, 6, 7 weeks and 2 days, 3 days before you're done. Yeah, so it's going to go by really fast. Got prom in here, got ACT date, so this was something that would really help me. If I could show you real quick here, the 2nd is the day that you guys take your AP exam. So if you notice, we are going to get 1, 2, 3, 4 weeks. We just get 4 weeks to prepare for the AP exam. It got moved up a week this year for the AP Calc. So that leaves us 1 less week than normal. But we'll still do our best. We'll get after it. But the year's going to go by pretty quick. So we start here. It says, sketch the slope field for x minus 1. Our AP exam? Or, yes, the AP exam for calculus is in the morning. Yep.
So
yep.
you do math.
Yep. And by the way, folks, your AP exams, when you have them, so we are not the only school unique to this. Everybody works with those. So if you have an AP exam that day and you also have, say, a track meet that day, okay, you go to the AP exam and then somebody drives you to the track meet. If you have a golf meet that day, then you drive to the golf meet. If it's going to conflict with the golf meet, then talk to your administration. But most of the time, people have to miss part of the golf meet. So, but that's a decision that's not made by me. That's a decision that's made by your administration. You would talk to them about that, okay? Go ahead. Try to draw the slope field for x minus 1. Take a minute and a half. Try to draw the slope field for x minus 1, okay? Go. Okay, so we want to draw the solution for, we want to draw the slope field for x minus 1. So again, you can pick any point. Suppose I pick the point 2, 1. So over 2 and up 1. The slope is equal to the x value, which is 2 minus 1. So at the coordinate 2, 1, you would draw a slope of just 1, because 2 minus 1 is 1. In fact, everywhere where x is 2, the slope is 1. These are things that eventually you have to catch on. Otherwise, you would have to plug it in every single time. If you have to do that, then so be it. When x is 1, the slope is 0. So all of these should be a 0 slope. All of these should be a negative 1 slope. These should all be a positive 2 slope, a negative 2, a negative 3, and a negative 4. Okay, that's what your slope field looks like. Easy peasy.
For the test, do you want us to fill in all the dots?
I will specify in your test how many dots I expect you to fill out. Okay, but just to be clear, I did that in about 38 seconds. If you had to plug every single one in, you're still going to have enough time with the amount of time I give you on the test. This is not a very long test. Okay, so now it says, this is where it becomes slightly new. It says, draw the solution for y of 0 is equal to 1. Is that what it says? Because mine's kind of cutting out. Y of 0 is equal to 1. Is that what it says? What that means is this. It passes through the coordinate x is 0 and y is 1. That's what it means. Okay? It passes through the coordinate 0, 1. So I'm going to go here and I'm going to put a dot on 0, 1. So I want to draw a curve that passes through that point and then maps according to the slope field. What I want you to do right now is do your very best to draw a shape that passes through this point and kind of fits in with the slope field. Try it on your own. Draw it light in case it's not right. Okay, just draw it light. Five, four, three, two, one. You should have something that looks like this. And that would be points for you on the AP exam. If you drew the particular solution correctly and you drew the slope field, you know, you get 2 or 3 points out of 9 just for doing that. That's not too hard, is it? Okay, so let's look at the even newer part. It says determine the general solution. So the general solution, I'll show you what that looks like. We say that dy over dx is equal to x minus 1. And this is why it's called separation of variables. We put everything, what's that? We put everything that has an x on one side and everything that has a y on another side. So this is new for you, but I'm going to multiply both sides by dx. And I get dy is equal to x minus 1 dx. Is everybody okay with that? Okay. And just for good measure, you see that there's an x minus 1 in front of the dx. I'm going to put a 1 in front of the dy. It's 1 times dy. Okay? So in order to find the solution, I have to get rid of the differential part. I don't want the dy or the dx. And so what I do is I do an operation to both sides, which is the antiderivative. Antiderivatives get rid of that dy and dx portion, don't they? So let's start with the right side. What is the integral of x minus 1? Over 2 plus a constant, right? And then on the left side, what would we say is the antiderivative of 1 with the variable dy? Just y. This is what we call the general solution. The general solution because it works for any given constant. What we want to do now is we want to determine the particular solution. Particular solution means y equals x squared over 2 minus x plus c given the coordinate 0, 1. So in other words, I'm trying to determine what would the c value be. What would the c value be if it passes through 0, 1? So you just simply plug in 0 for x. So y, or I'm sorry, what is the y value? 1. Y value is 1. So we have 1 equals 0 squared over 2 minus 0 plus c. C is equal to 1. And therefore, your equation is y equals x squared over 2 minus x plus 1. That is the particular solution. Nope.
Is there any other things attached to it?
Yeah, I mean, that's the easiest problem I could come up. You know, we're just trying to start baby steps. So yes, I'm trying to show you that so we can do more difficult things. You guys ready for the next one? Okay. This example says, determine the general and particular solutions for the following. Is this x over y, and is it y of 1 is equal to 2? Okay. So this is what we want to try to do. We first want to try to separate the variables. So I have dy over dx is equal to that x over y. So I want all the x's on one side, and I want all the y's on the other side. What could you do in order to make that happen? Yeah, if you just cross multiply, you notice you get y dy equals x dx. Okay with that? I would like to get rid of the dx and the dy. What do I do in order to make that happen? Integral. On the left-hand side, what do you get? Y squared over 2. And on the right side, I get x squared over 2 plus a constant. So to clarify, why do we put a constant on one side and not the other side? Well, if you think about it, suppose I put a plus c on this side as well. Couldn't I just subtract the c over and you would end up with just some constant over here? The point is there's some constant that we're adding back and forth. So you don't have to put them in both places. But this is right now what we have. But I need to solve for y. So what are you going to do to solve for y? Multiply by 2. So you get y squared is equal to just x squared plus, we don't have to write 2c, we can just write c because 2 times a constant is still a constant. Then we will square root. We get y is equal to plus or minus the square root of x squared plus a constant. That would be our general solution. Our general solution. So what would I do to find the particular solution?
Plug in 1, 2 for partials.
Yep, you're going to plug in 1 for the x value, you're going to plug in 2 for the y value. So 2 is equal to plus or minus the square root of, and for x we plug in 1 squared plus a constant. So what do I do to both sides? Square it. And you get 4 is equal to, and you square a positive or negative, they both come out positive, right? So you just get 4 is equal to 1 plus c. So therefore c is equal to? C is equal to 3. That's not bad, is it? You're right. My particular solution is then y is equal to plus or minus the square root of x squared plus 3. So let's just talk about the scoring here. First of all, if you separated the variables, they would give you a point on the AP exam. If you took the appropriate antiderivative and you got the y squared over 2 and the x squared over 2, they'd give you 1 point on the AP exam for that step. If you solve for the general solution, they give you a point for that. If you went for the particular solution, they give you a point for that. Usually this is a 9-point problem, and it's divided up amongst trying to find the particular solution, and usually there's some type of slope field to go with it from the beginning. So when we get to that 4-week time, we're preparing for the AP exam. You guys are going to look at these free response questions. You're going to try to work through them and figure them out. Now, the most challenging part of this, I think you would realize, is that this whole antiderivative thing, we've looked at pretty easy antiderivatives so far, haven't we? So think of all the antiderivatives and techniques we've done over this time. It's time to try just ones that are a little bit more challenging. There's a reason why this is a 2-day lesson, okay? So let's look at one that's a little bit more challenging. Is this dy over dx is equal to y over x, and y of 2 is equal to 2?
Yep.
Okay. Separate the variables.
Yeah, no,
We just
second.
What is it really? Monday, May 8th?
Oh, I did the second part of the work.
We'll figure it out. Okay. So what I did is I multiplied both sides by 1 over y to get rid of the y in the top, and I multiplied both sides by by dx to get the 1 over x dx. Do people see how I got there, or do you mean to work that out? Okay. So if I cross multiply, I would get x dy is equal to y dx. Everybody see that? Well, your x's and y's are definitely not on the appropriate sides, are they? So I'll divide both sides by y. And if I do that, I get x over y is equal to, or x over y dy is equal to dx. Are you okay with that? And if I divide both sides by x, you get 1 over y dy is equal to 1 over x dx. I'll try once more. If you cross multiply and you get x dy is equal to y dx, suppose I divide both sides by xy. Notice as I divide by xy, here the x's go away, you're left with 1 over y, and here you're left with 1 over x. See it now? Okay. Here we go. 1 over y dy. What do I need to now do to both sides? Antiderivative of 1 over y.
Natural log of the absolute value of y dy.
Natural log, absolute value of y. dy goes away. Equals?
Natural log of the absolute value of x.
Natural log of the absolute value of x. Plus a constant. Okay, we're down the right path there. I have to solve for y. How do you make natural log go away? Create a base of e. Base there, base there. Last year, chapter 4. Okay, those go away. You're left with the absolute value of y is equal to, now because this has a plus c attached onto it, you cannot cancel out the natural log. This is e to the natural log of the absolute value of x plus a constant.
That at the end. Are you multiplying it by e, or?
I'm creating a base of e. This is definitely not multiplying.
So you're turning the entire thing to an exponent?
Yes.
You can just do that?
You can just do that. Now, there's some logic here you need to be able to work. Yes. Because you have a plus c attached onto it here. We have a plus c attached onto it. So we eventually can make it go away, and I'll show you how in just a second here. But the first thing I want you to realize is, if you take e to a power, can that ever come out to be negative? No. So e to the power is always positive. Therefore, we don't have to have an absolute value sign anymore. We could just have y is equal to e to the natural log of the absolute value of x plus a constant. Anytime you take e to a power, it's going to be positive. All right, the second piece of logic that I need you to be able to work through, and this is something that gets used a lot. You've now seen a number of examples, so you understand the process, but this plus c thing can be dealt with in a nice way. And we're going to get to Lissa's question as well. Y equals e to the natural log of the absolute value of x times e to the c. Notice how if you have the same bases, you add the exponents, don't you? Well, e is just a number, and if you take a number to a constant, you're just going to come up with some other constant, aren't you? And so the way that people generally write this is y is equal to, instead of e to the c, they just put that constant out front. They say some type of constant times e to the natural log of the absolute value of x. Okay. Now, Alyssa looks at this. She says, e to the natural log. That should be able to cancel now, shouldn't it? And it does. So y is equal to c times the absolute value of x. That is my general solution. Notice how the constant is not adding anymore. The constant is multiplying in this scenario. Can I now find my particular solution? You can. We'll plug in 2 for y and 2 for x. 2 is equal to some constant times the absolute value of 2. And what do you get? C is equal to 1. So therefore, the particular solution is y is equal to the absolute value of x. So CLC is 1. CLC is 1. We try one more for today, one more for today.
Wait, but how did we know that
We knew x was 2 because you have this right here. Y of 2 is equal to 2. So it means x is 2 and y is 2. This means it goes through the coordinate of 2, 2.
Oh,
Okay? Yes. So, did you follow how we got to this spot? So, do you agree that C has to be 1? So therefore, I just put a 1 for C. Okay, last example for the day. dy over dx equal to 2e to the x plus y, where y of 0 is equal to 0. All right, a little bit different scenario now. Shoot, how do we separate those variables? I have an x and a y up in the exponent. Who's got a good thought? I just gave you an idea. Good. Any idea how we can move our variables around to get them on the same side? Yeah, I'll divide by e to the y. So 1 over e to the y dy is equal to 2e to the x dx. Is not 1 over e to the y the same thing as e to the negative y? So e to the negative y dy is equal to 2e to the x dx. Cool. So if you separated your variables correctly on the AP exam, you get a point for that. You can see it's a little bit more challenging than the first ones we started with. Now, what? Antiderivative, good. Let's do the easy side. The antiderivative of the right side will be 2e to the x plus a constant. Anybody know the antiderivative of e to the negative y? Negative e to the negative y. If you're struggling to see that, remember the derivative of e to the y is what? E to the y. But if you have e to the negative y, the derivative is going to be, you have to use a chain rule. And what's the derivative of negative y? Negative 1 times e to the negative y. So you see when you take the derivative or the antiderivative of that situation, you're going to produce a negative as a result. Good, so you've got that negative. All right, I've got to try to get at this y right there. What are you going to do? Multiply by a negative. E to the negative y is equal to negative 2 e to the x plus a constant. How do I get rid of a base of e? Natural log both sides. Doesn't matter whether it's positive or negative. Okay. So I do the natural log. You can see I end up here with a negative y is equal to the natural log of the absolute value. Whoops, I don't need that absolute value. I didn't take an antiderivative. Negative 2 e to the x plus c. And then how do I get rid of the negative? Yep, so I get y is equal to negative natural log of negative 2 e to the x plus a constant. Notice how the constant is on the inside of the natural logarithm. That's what's really important there. So that's the general solution. What we want to do is we want to come up with the particular solution. So what are we going to plug in?
0.
So if you plug in 0 for both, we get 0 on the left-hand side. And then on the right-hand side, we get negative natural log of negative 2 times e to the 0. What is e to the 0? 1. So negative 2 plus a constant. So I've got to solve for c. How do I solve for c? Yeah, first we got to get rid of the negative though, right? If you divide by a negative, still get 0 is equal to the natural log of negative 2 plus c. Slap an e on both. E to the 0 is 1, is equal to negative 2 plus c. 3 is equal to c. So your particular solution I'll write in green is that y equals negative natural log of negative 2 e to the x plus 3. That's your particular solution. So the process remains the same by the way in which we get there. You know, sometimes challenging if you end up with e or natural log. You can see the next one's going to be different in that we have two variables that are multiplied by each other. Okay, and that's what we will pick up with tomorrow is this one and this one. So if you would like to, please take out your homework. You have enough to at least get started for